Hello my dear children. In the previous class we have discussed different types of sums in finding continuity of a function at a given point. There are three types. Okay my dear children. Now come to the exercise 5.1 sums. See here exercise 5.1 sum. Question number 1. Prove that the function f of x is equal to 5x minus 3 is continuous at x is equal to 0, at x is equal to minus 3, at x is equal to 5. At these 3 points separately we have to find the function f is continuous. We have to prove that f is continuous at these 3 points separately. Understood the question my dear children? Right. Now come to the solution part. First of all, we have written given function, that is f of x is equal to 5x minus 3. So first case, first point, x is equal to 0. So to prove the continuity of f at x is equal to 0, here you have to recall the definition of continuity of a function at a given point. When the function is said to be continuous at a given point, the limit of the function at that particular point is equal to the value of the function at that particular point. If they are equal, then we can say that it is a continuous function. So for that we are finding here limit of f as extends to 0, limit f of x is equal to, as extends to 0, limit, what is f of x here? 5x minus 3. So we are writing that function here. Understood my dear children? Right. That is equal to here we have to find the limit of this function by substitution method. You know different methods are there to find the limit of a function. First method, first and foremost method is substitution method. So in the place of x we substitute x is equal to 0. So 5 into 0 minus 3. Understood this step my dear children? Right. Now by simplifying these two terms we get to minus 3. Understood that step my dear children? Right. Now we are finding the function value at 0. Okay my dear children? So f of 0 is equal to, in this given function we are substituting x is equal to 0. So 5 into 0 minus 3. By substituting x is equal to 0, we get this step. Understood my dear children? Right. By simplifying these two terms we get here minus 3. Understood this step my dear children? Right. Now if we observe these two values are equal here as extends to 0, limit f of x is equal to f of 0. Both values are equal. Hence f is said to be continuous at x is equal to 0. Hence proved. Understood my dear children? So the first part of the question is over. Similarly, we have to prove the function f is continuous at x is equal to minus 3. We follow the same steps. Similarly, we have to prove that the function f is continuous at x is equal to 5. Understood my dear children? Will you do that remaining part my dear children? Will you try it? Right. Similarly, do the second question. Question number 2 is also same as that of first question. Okay my dear children? That is why I am not explaining here. Now I am taking here question number 3, third question. See here third question, question number 3. First part, examine the function f of x is equal to x minus 5 for continuity. If you observe this question, here point is not mentioned, particularly a point is not given to check the continuity of the function. Okay my dear children? Now come to the solution part. Given f of x is equal to x minus 5. Here we have written the given function. Understood my dear children? Right. Because here no point is given particularly, we have taken a number, a real number a. let a be a real number. At this particular number, we verify the continuity of f at this particular real number. Okay, my dear children. So for that, first we find limit of that function at x is equal to a. So as x tends to a, limit f of x is equal to, as x tends to a, limit, what is f of x here? X minus 5. We substituted f of x here, x minus 5. Now we had to find limit of this function at x is equal to a. So substitution method. In the place of x, substitute a. So what do you get here? A minus 5. This is the limit of that function at x is equal to a. Now we have to find the function value at a. So f of a, we have to find f of a. This means the value of the function f at a. F of a is equal to, in this given function, just substitute x is equal to a. Then what will you get here? A minus 5. Here limit is a minus 5, and function value at that particular point is also a minus 5. Both are equal. Here as x tends to a, limit f of x is equal to f of a. Both are equal. Therefore f is continuous at x is equal to a. Therefore f is continuous at every real number a. Understood, my dear children? Right. Now come to the second part of the third question. Third question B. Examine the function f of x is equal to 1 by x minus 5. X is not equal to 5 for continuity. We have to examine, we have to check whether it is a continuous function or not. Understood the question, my dear children? Here also no point is given particularly. A particular point is not given for verifying the continuity of the function. Okay, my dear children. Now come to the solution part. Given f of x is equal to 1 by x minus 5, comma x is not equal to 5. As no particular point is given, we assume let a be a real number. Here we are assuming that a be a real number. We are taking one real number. Now we find limit of that function at x is equal to a. So as x tends to a, limit f of x is equal to, as x tends to a, limit, what is f of x here? 1 by x minus 5. So we wrote here 1 by x minus 5. Understood, my dear children? Right. Now we have to find the limit of this function at x is equal to a by substitution method only. So I substituted x is equal to 5 in this function. Then 1 by a minus 5. This is the limit limit of the function at x is equal to a. Now we have to find the function value at x is equal to a. It means in this given function we substitute x is equal to a. So f of a is equal to 1 by a minus 5. In this function we substitute x is equal to 5. Understood, my dear children? Right. Then we get f of a is equal to 1 by a minus 5. If you compare these two numbers, they are equal. They are equal or not? Yes, they are equal. Here as x tends to a, limit f of x is equal to f of a. Both values are same, equal. Therefore we can say that f is continuous at all points. At all real numbers, the function f is continuous, except at x is equal to 5. If x is equal to 5, in the denominator we get 0. 1 by 0, it is undefined, it is not a real number. Okay, my dear children? Understood? Right. Now come to the third part of the question number 3. Question number 3, third part. Examine the function f of x is equal to x square minus 25 by x plus 5, comma x is not equal to minus 5 for continuity. Here also a particular point is not given for verifying the continuity of the given function. So Here, first let us take the given function f of x is equal to x square minus 25 by x plus 5 comma x is not equal to minus 5. Now in the numerator we can write the factors x plus 5 into x minus 5 are the factors for the numerator divided by x plus 5. Understood this step, my dear children? Right. Now by striking out these two factors, what will you get here? X minus 5 only. This is nothing but the first part of this question. In the third question, first part, x minus 5, the given function. So the same function is given differently, but the function is same. Now we are verifying the continuity of this function at all real numbers. So let a be a real number because no particular point is given here. That is why we are assuming a real number a. Now we find limit of that function at x is equal to a. So as x tends to a, limit f of x is equal to, as x tends to a, limit x minus 5. We don't take this function, this only the real function. In a different way it is given like that, but actual function is x minus 5 only. So x minus 5. So we have to find the limit of this function at x is equal to a. So by using the substitution method we find the limit of that function. So in the place of x substitute a, so we get a minus 5. Understood this step, my dear children? Right. Now we find the value of f at a, that is f of a. F of a is equal to, in the function we substitute x is equal to a. Then what will you get here? A minus 5. So I wrote here a minus 5. Understood this step, my dear children? Right. Now we have to compare these two values. Are these two values the same or not? Yes, they are same. A minus 5. Here also a minus 5. Therefore here as x tends to a, limit f of x is equal to f of a. Therefore we can say that f is continuous at all points of its domain. Understood, my dear children? Right.